Hello, good morning everyone, Flash Flood experts. This is a recording for different sessions, and we are going to start with training one. This is the training materials for the flash floods over Dire Dawa in Ethiopia. When you open the training materials, you will find first there is a background about the project and also about the training. You can read this background at your convenient time. We can start first with Wflow training one, as I said. We have here an overview about Wflow and also some important installations. So first, this is the Wflow. It's available as a free open source Julia code. So this is a free source. Everyone can use this link to access the source. If you want to start your case study from scratch by yourself, you can use this link. I'm pasting the link here. So this is the source code. You can download the source code. This is what we call it the TOML file. This is the YML file, and these are everything needed for Wflow to start it from scratch if you want to start it yourself. For the Wflow, as I said, it's an open source. It uses like raster data as an input. It's very powerful over urban areas. It uses Python for this Wflow. It is like catchment scale runoff, rainfall runoff model, and fully distributed model. It means it calculates like everything at a pixel level, not at the catchment level. So we calculate everything at the pixel level here. This is also again a link for this open source, and the good thing also you can download this Wflow. So I'm copying now the link. So you can download the software. You will find it here, and you can download directly the software. Maybe also you need to log in and create an account here. You can log in, and you can create also an account. That is also possible. I already created, but you can register and create also your own account here at my Daltaris. So you can start first by creating your account at my Daltaris, although it is not necessary to download the exe file for Wflow, but it's better you create also your account. Then after that you can come here and you can start to download the executable file. And then when you double click the executable file after downloading and you go next, you will install the Wflow in your laptop or in your PC. There are some key strengths of this Wflow. First of all, as we said, it's an open source and it's free, also easy to set up, and we are going to see that how is it easy to set up, and it has directly linked with available gridded data set here. It uses also global parameterization of the model based on available global dataset. It is also strongly linked with Modathir, Delfuse, and Rebasing. These are other models like Modathir. This is a groundwater. Delfuse. This is a forecasting. Rebasing. This is like a water allocation model. So it is compatible with other models. The weakness slow compared to semi-distributed lumped model. And here, as you can see these three graphs, this is the lumped model. It calculates everything at this sub-basin level. This is semi-distributed. It calculates everything at this catchment level. The distributed model, it calculates everything at a pixel level. So all the processes, they were done at a pixel level. So you can get all the values here at a pixel level. That's why it makes the model very detailed, but it is slow, the model, compared with the other semi-distributed model. Sometimes if the basin or the sub-basin is big, of course, the output is large, and the learning curve to work with NetCDF format also, it needs some effort, and to work with Python for those who has limited experience in using NetCDF files as an input for the model, and also using Python. But we are going to go together through all these processes. But there are, of course, there are advantage of the gridded approach. There is a strong physical basis for simulation linked to soil properties and land use, land cover. So it represents better what happens on the ground, because when you average everything at catchment level, sometimes you miss if there are different land covers, or if there are different land use, so you miss some of these things. But when you work at the pixel level, you can capture many of these things on the ground. It is also linked well with some of these global dataset like Dire 5 or chirps. This is just a flow chart. We use normal observations like stream flow, Earth observations, Google Earth engine, and also some of these global dataset like the FAO data for the soil. It can also use some local data. All these become as data model, and then we use it as an input to force the model, or to force our Wflow hydrological model. And as I said, it is a fully distributed model, and uses gridded data input and output, and the result is available at each grid cell. So here at each grid cell, you can extract the result that you want. It's important that we know that, as we said, the model uses base maps like DEM, it uses land use map, it uses soil maps. There is also possibility to add lakes and reservoirs and the forcing data. And here we talk about potential evapotranspiration and rainfall. These are dynamical data. We use it also. The other important thing here to explore this data set, we need to install uh, the QGIS. It's important to install the QGIS. This is the link on how to install the QGIS. Thank you very much. This is the first session.